Hey, Trevor Matthews here with another morning coffee with Trevor. I'm your host, Trevor Matthews. And once again, thanks for joining and participating in these morning coffees. I've been enjoying the last week and a half and learned so much. And thanks for all the response emails from all of you on different topics you would like to hear and different discussions you would like to have. I'm going to start a different approach. I really want to help more people, help with competency, help them with knowledge, help them grow a bit more. So what I'm going to start doing, I'm actually going to do some knowledge assessments after these morning coffees. So I'm going to go through, I'm going to write a few different questions. I'm going to throw it down on like any social media platform that I put it on, like YouTube. Most of them are going right now. So I'm actually going to put a little knowledge assessment in there. So all you're going to have to do is click on it, go in and try to answer some of the questions, on the topics that we're talking about. I'm trying to build a competency of technicians out there, and it really will hopefully help you, challenge you a bit. Maybe you can just click on it and you know all the answers. You probably will know a lot of the stuff, but what I want to do is challenge you a little bit more from these different sessions that we're having while we're having a coffee. So over the next few days, I want to get into one of my favorite topics to talk about, and that is using CO2 as a refrigerant, so R-744. And this is something that is going to continue to grow. I started learning about CO2 as a refrigerant, R-744, back in 2014, and I started training on it probably 2015, 2016, learning about it, educating technicians about it. And since that time, I've seen CO2 as a refrigerant grow immensely, and it's going to continue to grow. And we need to start preparing ourselves to understand the differences between that refrigerant and other refrigerants out there. And when you're prepared and you understand it, it's going to make your job so much easier when you're working at it. Because I've seen and talked to so many technicians, even buddies in the field, they're like, Trevor, they didn't even know we had CO2 stores, and I was being called out to them during on-call. And there's so many different pieces of equipment out there. It's not just in the commercial refrigeration space. You have heat pumps as using CO2, and many large ones happening now, like big buildings changing into natural refrigerants. You got ice rinks using CO2, industrial plants, you got supermarket, and you got condensing units with CO2 as a refrigerant. So it's important to start to understand and see this, because there are differences. There is a lot of differences between using CO2 as a refrigerant, R-744, than like a standard HFC, HCFC, or an HFO. And so the thing you need to understand, though, is the biggest benefits of CO2 and why you're going to start to see R-744. The big one is the global warming potential. And a global warming potential of CO2 is 1. And then you'll see the standard HFC or CFCs, they're between 1,000 and 4,000 global warming potential. And I've talked about this previously, like these regulations have been changing globally, F-gas regulations, carb regulations, and it's really pushing towards more natural refrigerants. But you as a technician or somebody working with CO2, you just need to understand a lot of the safety factors of it. CO2 is a higher pressure than your standard refrigerants. So you'll have two different sides. Pressure, the operating pressure, standstill pressures, are different, and you're going to notice that when you work on any of these systems. They're going to be higher than your standard HFCs, and you're going to see in a range, like if you're talking about subcritical, when we'll get deeper into that stuff. So that's the low temp side. You're looking between 200 on your suction and 400 on your discharge, we'll say, and that's just round numbers. They'll be a bit different. But then on your high side, so that medium temp side, you'll be looking at like 400 on your suction and maybe 1,000 or 1,200 on your discharge. So a lot higher pressures than you'd see with your 404s, 134As, R22s, and you need to be aware of that. One great thing that I've noticed about using CO2, everything's electronic, so you can use and see what is going on the controllers or that PLC for that system. And it makes it so much easier because you don't really have to throw on gauges and stuff unless you're testing a lot of times, like if you're checking if a pressure transducer is working and something like that. You know, it's not flammable. It's, you know, it's an A1 inert gas, and it's, you know, there's no odor to it. So it's no different in that aspect compared to HFC or HCFC, but the volumetric mass flow is way higher, you know, like heat transfer is. And these are the different things that you need to take a look at and understand. Because you will be moving that gas through those pipes all at a different speed. You do need to use different type of equipment, you know, the equipment that can handle these higher pressure, higher standstill pressures. And in Europe, it's really growing in Europe. In North America, it is starting to grow fast. Even when I started, once again, back in 2014, there was, I don't even know if there was any CO2 stores. There might have been a few. The pump system, you know, secondary systems, there were some for sure, because I've worked on some of those before I started training on CO2. But even in the last 5 years, I've seen it almost double each year across North America, the amount of stores. Well, maybe not double, but it's for sure a 30 or 40% increase year over year on the amount of CO2 equipment in North America. One other good things about the refrigerant cost is very low, and it's something that so some of the issues that I've seen with it though is trying to get it. You know, wholesalers, or you don't just go to your wholesaler and grab it. Usually here in Canada anyway, you'll have Air Liquide or Praxair where you'll be finding this refrigerant. Some of the things you need to understand though is, I said it already, it's the higher pressure, but it is a bit more complex. That's why you need to start learning about it. There is more electronics in a CO2 system than a standard HFC system. And with the regulations and the way they're going and moving, you're going to see more of these equipment, more CO2 equipment. Good morning, everyone. Here's a question. Is CO2 as a refrigerant only applicable to transcritical systems? No. So secondary systems or pump systems, you'll see a lot of this in industrial application. I even worked on supermarkets. So on the high temp side, you'd have a synthetic refrigerant. You know, it could be 404, it could be ammonia, you know, it could be propane, it could be anything on that high side. And then on that lower side would be CO2. And so what you would have on that side, you'd have like a pump, and you'd have a chiller, you know, so a plate heat exchanger cooling down the CO2. And then that liquid refrigerant, there would be a centrifugal pump and would pump that liquid out to the cases, we'll say. So it's not only transcritical systems out there, but that's the ones that are growing very fast. You know, it's one of the bigger issues when I first started learning about it was, you know, high ambient. Like how do manufacturers deal with high ambient? Because you have the higher ambient, you're pushing that system into transcritical. And we'll talk about that, what transcritical is in a little bit. But it was how are we able to get equipment to work in really high ambient locations? But there's so many benefits about R-744 over synthetic refrigerants that you'll see over and over time. The things you need to understand is that with CO2 or R-744, there are the critical point and a triple point. It's a very small range. We don't talk about critical point when we're talking about say 404 or 507, you know, R22 or 134A, because they do have a critical point, but the ambients just don't reach it. They're like, you know, 160 Fahrenheit or, you know, 70 some Celsius, whatever it is. And we just, the ambients don't really get there. Even the hottest place on the planet, I think there's a record. I looked it up before. I can't remember what, maybe it's 134 Fahrenheit, that it got. And so the critical point of like 404 is like 150 or 160 Fahrenheit. And so we didn't ever see that critical point, where with CO2 refrigerant now, R-744, you'll see that critical point at 87.8 Fahrenheit or 31 Celsius. So you get that temperature really all over the world. You can get that temperature. So that is something you really need to think about. And then you get up into over this critical point, and now you're at what we call a supercritical fluid. So it's not, there's no pressure temperature relationship. So these are some of the cool things about CO2, but you need to be aware of that stuff to be able to service and troubleshoot it. And then the other thing is called the triple point. And that's really when you have the three phases. You'll have solid, liquid, and vapor. So, and really what happens when you're below the triple point, which is, what is it again, 61 PSI. I think it's 3 bar, 2 bar. No, it's maybe 4 bar. I'll have to look that stuff up again. I got to get better with my different units. But below that, as you're below your triple point, you can turn liquid CO2 right into dry ice. And so that's something you need to be aware as well as a service technician. If you're going to work on it, you're going to pull off, say, the liquid line filter, and all of a sudden it's still full of liquid, and you'll get dry ice. But even that's not that big of a deal, because you can deal with that. That's not really going to hurt you. You know what I mean? What could hurt you if you trap liquid in a system, and that's one of the differences between CO2 and a synthetic, is that if you trap it improperly, so you don't know how to safely work on it, it could expand a lot quicker, and it expands rapidly. So you need to understand this. And as a technician, you got to do things differently. And one thing that I learned about CO2, doing all the trainings, training the hundreds and hundreds of technicians and doing all the talk, one of the big things is, which I like, is that as a technician, you have to do the job properly. You have to work on the system. You can't take any cuts and corners, like evacuation, setting up, design. And CO2 for manufacturers now, they're getting better at building the equipment. So there's going to be a point where you're not going to have to worry about standstill pressure. I talked about that. You got rapid rise in pressures when CO2 is just sitting there. I think at 68 Fahrenheit or 20 Celsius, you're looking at 800 and some PSI, right? So that's in a cylinder, like sitting in the cylinder. So that's quite a high temperature. And it's important to understand how to look at these systems and work on these different systems, because it's not, like I said, it's not only going to be in commercial supermarket or market refrigeration. You're going to see them in heat pumps. You're going to see them in ice rinks. You're seeing them already. Some of the characteristics of CO2 is that at atmospheric pressures, like minus 110 Fahrenheit, like it's super cold, or like minus 79 Celsius. So that is very, very cold. And I believe that's the temperature of dry ice, and what dry ice is something that you need to understand as well. I don't know if you're a technician and you work commercial refrigeration. I've seen it where I went into stores, and a box was down, and the store owners would throw a bunch of dry ice in that cooler. So you need to be aware of that as well. This is something that can start displacing the air, because when you have dry ice, it sublimates. So something you need to understand. That's all right. Critical pressure. What is the critical pressure? It's around 1,055 PSI. That's at the point when it's going to go into that transcritical phase or supercritical phase of that. So these are some of the things that you need to understand and be aware of. Do not trap CO2 as a liquid. Understand that controls that you're going to work on. That's one of the big things. And it doesn't matter even if we're talking CO2 or not. You need to start learning electronics and controls. It's just happening. We're gonna become more control technicians than just standard working on mechanical pieces of equipment. That's just the way the industry's going. That's what manufacturers are doing, making the equipment more efficient and effective. So you can troubleshoot equipment either quicker or solve a problem faster. And we've been seeing this year over year. You see it in all sides of refrigeration and HVAC. You get diagnostics features on, residential equipment, commercial equipment, as well as industrial equipment. So you need to start understanding controls if you don't understand them now, because condensing units have them, heat pump has them, VRF, all these equipment is all electronics, and it's no different with CO2 equipment. And you want to start learning that stuff. You really want to start learning that stuff. So some of the real big things that I've talked about, and I can't stress enough, is understanding CO2 and really in a pressure enthalpy diagram. When you look at it on a CO2 on an enthalpy diagram, I highly recommend going into Danfoss's Cool Selector 2. They have all these enthalpy diagrams on there. You can take a look at it. There is a lot of lines. You can remove them, play around with it, but it's going to show you when you're in a transcritical cycle or a subcritical cycle. That's how you talk in CO2. Is it in transcritical or subcritical? So your low side is in subcritical. All the equipment you work on today is in subcritical. It doesn't matter if it's high temp, medium temp, low temp. All that is running in the subcritical zone. And really what that means is that you have your heat of compression, your compressor, you got your condenser that you will condense inside that condenser. Then you'll have your liquid line going to either your medium temp, and then you'll have your evaporator. And that would be your subcritical cycle, standard medium temp, low temp system. You got your compressor, condenser, metering device, and evaporator. When we look at a CO2 system now, you're in subcritical when you're below that critical point. That 87 point, 87.7, I think, or 31 degrees Celsius. You're below that critical point. But when you're above that, that's when you're in that transcritical cycle. You're in that transcritical zone, and it's there's no pressure temperature relationship. You really need to understand that, because leaving that gas cooler is just gas, but it's really fluid. It's not vapor, it's not liquid, but it's a fluid. So inside the controllers, you need to understand how to maintain that gas cooler condenser. Because some people think, oh, it's just a condenser. Well, no, it's not. You're not condensing when you're above that critical point. These are some of the key things you need to understand when you're working on it, and understand how it works. It's so important to understand how it works and what is going on inside that system as that is flowing, that mass flow going through there, because it's different. And the characteristics of CO2, the way it carries oil through the system, is totally different than the way it carries R-22 through the system. Higher velocities, different characteristics, different compatibilities. And there's things that you need to understand, and why it's so important to read the manuals. You should be reading the manuals anyway. You should be reading the manuals of any equipment you're working on, but definitely with CO2, you should be. Morning, Victor, Lowell, George. So, Lowell, yes, CO2 is already in residential applications. For example, heat pump applications.
Good morning, Trevor.
Hey, Victor, how you doing? Yeah, so you're going to see it in all types of applications. I've seen, if you look up Yeah, for example, it's like I said, the heat pump application. If you go online, and you look up residential CO2, what was it again? Residential heat pumps using CO2. I think that'll pop up. There's lots of manufacturers working on that already. So, and you're going to see it more and more. You're going to see it grow and grow as regulations change and develop globally. Just going to be aware of this. And the big thing is safety. Proper PPE is so important. Where we could get a little bit complacent as a technician using the refrigerants today, still lots of people get hurt. I've seen lots of people get hurt even with synthetic refrigerants. I've met one guy who had an R-22 cylinder and it fell off the back of the truck, broke the head off, cracked it, and he tried to put the valve back on, and he didn't have a glove on, and he burnt all the skin off his hand. I'm sure technicians yourself that have got hurt in the field. So it's all about being safe, understanding what you're doing, what you're working on, and being safe, wearing your safety glasses, your boots, wearing a harness when you need it, having respirators when you're burning in equipment, that, because I've got hit with phosgene quite a few times, and that's really just burning refrigerant, and it burns your eyes, and you can really hurt yourself, and you don't want that to happen or hurt others. So in our industry, we need to be safe. You need to take care of yourself. So how are you going to work if you're hurt? How are you going to provide for your family if you can't work? Ladder safety is another big one. You need to stay on top of that and protect yourself. Yeah, so talked about the triple point. That's really where the solid, liquid, and vapor phase meets, and below that triple point, minus 69 Fahrenheit, 70 Fahrenheit, that's where it turns into dry ice. And I've seen this multiple times. I've even done it on a system where I've wanted to see if I could make it into dry ice, and I had it happen in a filter dryer, liquid line filter dryer, to test it to see. One cool thing about when I did work at Copeland, in the training system that I was using to train technicians on, the equipment was built by a company called Septec Technologies. Very smart OEM, no CO2 inside and out, and they've developed this phase change station, which was really cool, where you could take CO2 and turn it in this little station, changing the pressures. You'd fill it up with liquid, and then you'd put it above the critical point, and you could see how it changed into like I didn't even know, a plasma or some sort of fluid, because it doesn't look like vapor and it doesn't look like liquid. Then you could push it back down below that, and you could see that the difference between the vapor and the liquid. And then you could even push it and make dry ice, which was really cool to do it, and giving you a perspective, because you can watch the pressures at the same time, and the temperatures, the pressure, sorry. And it really gave you an idea of what's happening or what could happen inside that system, because you can see the pressures rise really rapidly, and you can see, you can see the pressures drop to turn it into that dry ice. Anybody have experience working with CO2 as a refrigerant yet? Or is it in where you're even from? Do you even have any equipment that you know of in your country? Not sure, it's all good. So depending on the design of the system, you may want to push your system into that transcritical mode. I know here in Canada, they do quite a bit to use heat reclaim or heat recovery to preheat water, to heat areas in their building. So you may want to push it up into that supercritical zone or transcritical zone to get the heat from there. And that's why you're seeing more and more heat pumps being designed with CO2. It's very, there's lots of efficiencies using that. And right now, I know if you're not working on CO2, and it doesn't matter where you're at in the world, you are going to see at some point CO2 equipment where you're at. And it doesn't matter the temperature anymore, because there's these strategies, these designs, these developments that are making it more efficient to work in those climates. And then regulation is going to push it as well to get into that. There's lots of different handbooks. There's lots of different information. What's great about the internet today is that you can find lots of information. And I really recommend spending time on learning about the CO2 and different books and manuals and education on it, because you will see it. And I've read lots of them, and I have lots more to read. I've read dozens to hundreds of manuals on CO2 just to upskill myself, to educate and train other people on CO2 and technicians, because I know this is going to be seen, and it's going to be a well-known refrigerant. It's not like it's a new refrigerant. Back in the early 1900s, they used CO2. You know, I mean, even before that, they were using CO2, but CO2 kind of went away when synthetic refrigerants were developed. And it's kind of like most of the other refrigerants, besides like ammonia. Ammonia as a natural refrigerant has been just plugging away for so long, and it's such a great refrigerant. It has the highest really net refrigeration effect out of all the refrigerants. So these are different things that you should be learning about as a refrigeration technician, as a refrigeration mechanic. You should be understanding all sides of the industry, at least having the basic concepts of it. Because one thing that I've noticed, even here in Canada, we have one of the greatest education systems, I say, for refrigeration, because you have to do an apprenticeship, and it's 4 or 5 years, and you have to do so many hours. But one of the things is it's not segmented. So what I mean by that is that when you finish your, say, 4 or 5 years and you become a refrigeration technician or mechanic, you didn't, dive into that industrial side a lot, you know what I mean? Or you didn't dive into a supermarket or commercial refrigeration lot. So you're just touching on a lot of these different things. So as contractors, what they have to do is really help develop and grow those technicians in those specific fields. Because for me, industrial is a totally different trade than commercial, and definitely than residential. Like there's so, and you couldn't just take a industrial guy and just put them down on a residential unit and say, here's a furnace, okay, check the static pressure and all this. And it's no different. You couldn't take a residential guy and do industrial. I'm not saying there isn't technicians that can do that, because I've worked on a lot of different stuff, and there's lots that are out there. But for the standard and average tech that just works day in, day out on residential stuff, there's a huge learning curve. And that's what I'm trying to get at. You need to understand the equipment you're working on, but you need to at least as well have a base understanding of those different sides of refrigeration, right? So when you're having a conversation with someone in industrial or commercial or residential, that you can at least have that conversation. And CO2, you're going to see coming up more and more in different conversations, and because it is growing. From when I first started in like 7-8 years ago, in learning about CO2, I think there was only a couple of CO2 stores in Canada, and there's probably over 400 now, like Transcritical stores. In the US, there was only a couple. There's probably upwards to 1,000, I would say. And then globally, there's tens of thousands, and these are just Transcritical supermarket stores. Not talking about heat pumps and these other applications they're coming out with. Even the air conditioning use CO2, and there's some testing for data centers. Lots of the different applications. A great resource for you to go if you want to learn more about it is R-744.com. You can go there and check for lots of different information, as well as just go on Google and just kind of do a research for CO2 as a refrigerant, R-744, and you're going to learn more and more about it. You got to take the time to spend on it. The big thing is, I talked about it nearly the whole time, it's about safety. Safety, understanding how that affects the system and how that really works. Well, like I said already, I'm going to actually put a knowledge assessment of just the things that I've talked about, a few questions for you, for those who have been listening the whole time, and you can go in and challenge yourself. See if you remember some of the things that we talked about over here the last 30 minutes. And want everyone to have a fantastic rest of their day. And let's get a conversation going. Have a great one.